$11,000. It's the amount of money I spent in lab equipment alone to study for my CCIE routing and switching certification. Now that's lab equipment alone. I'm not talking testing fees or anything like that. Just buying routers and switches off of eBay to study. That's what it was all about. And that's I would say the tangible expense. The intangible, I can't even calculate. I mean, my office, I mean, don't get me wrong, I loved it. This was the glory days. A 2-post rack, just more Cisco routers and switches than you can imagine, all linked up with all kinds of cables. It was like I had my own data center. Or at least I wish I did. But the problem is I wasn't in a data center. I wish I was. I was in my house. I was in my house where I would hit the button to turn them all on, and literally the lights in my office would go whoom. You would kind of feel the power flux go into the rack. If my wife printed anything to the laser printer while I was studying, it would blow a breaker and everything would shut down. So that had to change. And likewise, like I said, I wish it were a data center because it'd be cool. But instead, I live in Phoenix, Arizona, where the temperature outside is 100 degrees plus for half the year. And the temperature in my office probably doubled that. Or at least it felt that way. I couldn't study without taking a shower afterwards. I was just dripping just because it was so hot. I say all this because if somebody could have teleported in time and told me back in the day, Jeremy, hey, there's something else out there. Well, there wasn't back when I was studying, but if there could have been, I would have been all ears. That's what I'm here to tell you today. Wow, I just felt like a telesalesperson. So let me sign you up for a 6-month plan. But the thing is, I'm not selling anything. I'm talking about GNS3, a free product that you can use in your Cisco routing studies, which goes right in line with this Cisco route certification exam. Let's talk about it. GNS3 stands for Graphical Network Simulator. It is an open source community project, so it's free. Nobody's looking for any money other than maybe some donations to the guy who created it, who, by the way, is named Jeremy. It's not me, though. I wish it were. But I unfortunately do not have any skill in programming whatsoever. So this guy named Jeremy, he's actually from France, headed up this project that provides a Cisco emulation on Windows and Linux. Now, that's I would say the biggest difference. And it's funny, the name kind of discredits it. You see simulator, and you think about things like on the Cisco exam. And you've experienced that. You take a Cisco exam, it comes up with a simulation. It says you have to configure this router to be able to ping that device or something like that. And you have to go in and kind of toy around with the simulation and do it. And you know, if you've done one of those, that if you go outside the bounds of what they're looking for you to do, it's going to pop up a message saying, I'm sorry, that command is not supported in this simulation, because it is, in the end, a simulation. It's kind of like if you were studying to learn how to drive, if you remember that. Back in high school, I took driver's ed, where they had a little, you would sit at a driving simulator. It's a steering wheel, and they would play a movie on a projected screen that would show you driving, and you're supposed to turn the wheel to kind of feel like you're driving. Well, like every stupid high school kid, you know it's not real, so you're just going, turning the wheel every which direction, because you know it's a simulation. It doesn't matter. It's not real. But what if they said, well, let's do a driving emulation, which means you're going to go out on the road, you're going to be driving a real car, but it just goes really slow. That's what GNS3 really is. It emulates a Cisco router, meaning it boots the real iOS, the real software, and it is, in all essence, it pings, it works just like a real Cisco device. And I stopped short of saying it is a real Cisco device because you can't touch it. It's not there in front of you. It's running on your computer. So it's emulating it, but it goes really slow. Not meaning it's not responsive, like you type a command and you're waiting for it. I'm just talking packet throughput. It provides 1,000 packets per second throughput, which sounds like a lot, but when you compare that to a real router, I mean, a real router, you're talking 50, 100 times that amount for a huge production router. This is not meant to be a production router. It's meant to be for lab environments to study. So no more cooling costs, no more $11,000 spent on eBay equipment, no more, et cetera, et cetera, et cetera. You've got everything that you can emulate in your own environment using a fancy GUI. And that's really what this Jeremy guy in France designed. He did not build the Cisco emulation piece. That was actually a community project known as DynaMIPS and DynaGen. If you want more info on that, you can Google it and find out its roots and everything like that. And they're still developing that. It was originally for Linux, a way of emulating a Cisco router on Linux. But it was, I mean, it's a Linux project. If you've dealt with Linux, you know, you've got to toy with stuff. You've got dependencies. It's a pain to get set up. So what GNS3 is a Windows interface or Macintosh OS X kind of thing where you can go in. Let me show it to you. This is the website, and you can see this is the main site right here, gns3.net. You go right here. This is, you know, you can download it. I think he takes donations. There you go, donations to support. You know, buy him a cup of coffee or whatever the case is. But if you look at it, this is what it looks like. It looks just like, you know, a Visio diagram. But the thing is you actually assign Cisco iOS images to these guys and boot them. Now there's actually a project. Very few people know about it, but you can Google out. It's no longer top secret. Cisco used to have, and they still do have, an internal project known as IOU. That's Cisco iOS on Unix. And I knew about this back when I was spending $11,000. I was like, if I could only get my hands on IOU, which it runs on Solaris and that kind of thing, then I would be able to you know, work with and troubleshoot and all this kind of stuff, the real iOS. But you know, IOU is now quote-unquote old news, if you will, because GNS3 does the same thing. You can build connections with this thing, set them up, you can boot them, and then it boots up as the real iOS. Everything works. You can ping between these devices, set up routing protocols. Everything is there, just like the real devices. And you can get really big, depending on the size of your computer, really big topologies, like CCIE style. And you can see, look at this. This is a Macintosh right here that they're running it on. So OS X, Windows, it works just fine, and it works amazingly well. So I will also say, you know, I'm kind of like, ooh, what's this? I'm going through all the screen caps. That it will take some toying with it, which is why I created this nugget. It's because I want to explain, you know, some of the tips to move you along with GNS3 on how to set it up, how to get it working, all that kind of stuff. So last couple things. GNS3 is router emulation, and it also does ASA PICs. It does Juniper if you want to do that heathen company. Just Juniper's great, but it is a completely different system. It does not support switches, and that's because Cisco uses ASICs, kind of a proprietary hardware to run their switches, and it would be a lot of work to create an emulation an emulation engine, I should say, for ASICs. So instead, what they do is they use ether switch modules, which looks something like this. If you haven't seen an ether switch, it's a switch inside of a router, kind of like this, to simulate switches. And you get the same feel, same commands, same VLANs you can create, all that kind of stuff. It's just inside of a router to do it, rather than actually having a switch design. Well, enough about what it is. You'll learn more of what it is as we set it up and get it configured. So let's actually start there. Getting GNS3. This is as easy as going to the web page, hitting the downloads area or the download link, and downloading it. Now everything I talk about here is going to be on Windows, but know that you can do this on OS X or Linux and compile the sources and so on. But Windows, they have a convenient all-in-one that has DynaMIPS, which is the emulator for routers, QEMU and PEMU, which is our PICs and ASA emulator, and then PuTTY and WinPCAP. PuTTY being PuTTY, our console client, Telnet client, and WinPCAP is from good old Wireshark world. Allows your network card to operate in promiscuous mode. So you download that, and it does it all for you. Now, while you're here, you know, again, you can download that. It's on my desktop. But also, something else you'll want to grab is this guy, Cisco Image Unpacker. Decompresses the iOS image. More on that later. Just for now, you can download that. And you can see that's what I've done right here. There's my installer. I went through the install because it's literally a no-brainer. There are no questions asked that you need any intelligent response to. It's just next, finish kind of thing. And once you do, you have GNS3 sitting there on your desktop. So your next step now is to locate and decompress a Cisco iOS image. Now that's probably the #1 question the people at GNS3 get, and for their support forms, where do I get the Cisco iOS from? You just do. you buy a Cisco router off of eBay for study purposes. Maybe use it as a home router. Grab the iOS off of there, as long as it's one of these versions. These are all the different versions. You can grab one from a friend. Just remember, GNS3 is for lab and testing purposes. Obviously, the iOS is something that you use on a production Cisco router. This is not a production. This is for your studies only, all that kind of thing. So you grab the iOS image. You get that and you put it on your desktop. Now, right here you can see the iOS image, which is my C2600 Advanced Enterprise. Now this iOS image is in compressed format. It's a binary file, a .bin. And if you've worked with Cisco routers, you know you put these in the flash memory, you use TFTP. But the problem with keeping them in binary format is it's compressed. And this is the number one slow, painfully slow thing that you go through every single time you boot a Cisco router. You watch the pound symbols going across the screen, and you're just going, ugh. Well, imagine that, compound that, 8-time fold when you've got 8 routers that you hit the play button on and they all start in GNS3 at once. It's going to take forever to boot them. So that's where you can use that image unpacker that I mentioned right here. The image unpacker decompresses the binary file. And you can see just how compressed it was. It was 30 megabytes before. Now it's 72 megabytes in size. But then you can use this uncompressed file or decompressed file within GNS3, and it boots lightning fast. The router's up and running before you, most of the time, can even open the window to connect to it. It's very quick to get things running. So save yourself a lot of time. Just get the image unpacker and use that. Then we come to GNS3. As soon as you open it up, it comes up with a simple setup wizard. You can see 2 steps. It says configure and test the path to Dynamips. Also check the working directory is valid. So Dynamips, as you might remember, I talked about it on the what, is the real engine behind this. Again, Jeremy, the guy in France, did not develop Dynamips. He just developed kind of a graphical interface and an easy to use interface to make Dynamips work without having to be a Linux guru. So you click on this little step 1, it automatically opens, hey, what do you want your paths to be? A couple things that I'll mention is, first thing you want to do is change your project directory to something real, meaning you don't want it to throw it in this temporary folder because you'll never find your projects. Now your projects are the GNS3 operations that you're working on, meaning as you're designing your topology, you're configuring your routers, that's all considered your GNS3 project. So we'll browse and let's just, for now, throw that on our desktop in a folder called GNS3 projects. Okay, and okay. We change that directory to something that we can find. Same thing with the image directory. The image directory is where is your Cisco iOS images coming from. So for now, I'll just point it at my 2621 XM folder and click on OK. And then from there, the main thing that it's wanting you to do is check your Dynamips. Now, thankfully, Dynamips is just kind of there. It's running. It's installed when you get GNS installed on your computer. So normally the executable path is fine. You can leave it at the default, the working directory. You want to hit test. Test this feature. To make sure that the Dynamips is running. And you should get this Dynamips successfully started, which means kind of the engine behind the scene is running. Now, I should also mention at this point that I am not a GNS3 or Dynamips super guru. I know enough to get it working and make it work well for lab environments, but there are some features that are huge. For instance, this Ghost iOS feature. And this ties right to it, the memory, I think it's memory map is what that stands for. Ghost iOS, what it does is, well, I'll say without this feature, every single time you boot a Cisco router, it's going to eat a chunk of memory, meaning whatever amount of memory the iOS takes. In our case, it would be about 72 megabytes of memory because that goes straight into RAM. So if you've got 8 routers running a 72 megabyte image, you can gather you're pretty well getting up to 500-600 megabytes of memory that you're consuming. What this Ghost iOS does is allow you to share one memory resident iOS image among all your routers. So your memory consumption for GNS3 goes really low. It's awesome. I also want to mention that there is things like hypervisor. I mean, you can offload GNS3 processing to other areas of your network. For instance, another server that has a huge processor. You can say, okay, you run the iOS images and things like that. So there's a lot that you can do with this. Likewise, you can do Wireshark captures. This, and I'll show you this later, it's awesome to be able to actually capture packets from this virtual network and analyze them. Huge for training. I mean, just mind-blowingly huge. So anyway, I came here to just test Dynamips, so I'll click on OK. My screen's a little small. Let me see if I can. How do you auto hide that guy? Auto hide. There we go. Get a little more real estate. There we go. So we've got GNS3 is initially set up. We click on OK, and then it says Step 2, add one or more uncompressed iOS images. Now, this depends on what iOS you have. Now, realize that obviously I'm not going to be able to use my 2621 iOS for a 3700 series router. You have to get your platform specific iOS. So I'll go in here and I'll say, okay, the image file that I have, and choose the unpacked guy. This unpacked, otherwise you got to boot them every time. Click on that. Is my 2600 series right here. Platform C2600. The model, it is actually a 2621XM router. It shows the default RAM that I have assigned. I think that's enough. I might need to. I think it might be 128. I think it is 128 that I need to give to this platform. And then it says, default image for this platform. I'll hit fine. That's saved. So it's now saved and it's good to go. So this is now an iOS that I have available. So at this point, I can drag and drop 2600 series routers and it's going to use this iOS for them. If I try and drag and drop something else, it's going to say, sorry, you don't have the right image for that. Something else I want you to see for now, I'll talk about it later, is this idle PC value. The idle PC is mind-blowingly huge for GNS3. Again, we'll come back to it. Just for now, I just want you to see that that value is there. I'll click on Save. Save and then Close. I was waiting for something to happen. It didn't. So I click on Close, and now I'm okay. I'm set up. I'm ready to go. So here's my kind of landscape for GNS3. And actually, let me get back here. I've got my iOS image added for my 2621XM. I'm going to drag and drop to build my topology. So as I was saying right here, this is my landscape for GNS3. Now, mind you, I'm running it in 800 by 600 resolution. Normally, you have a lot more real estate that you can play with, but this will do to demonstrate it. So I'm going to grab my 2600 series router. Well, let me show you this. If I grab a 1700 series router and drop it on there, it's going to say you can't do that. You haven't specified an image. But as for the 2600 series, I'll drag and drop that onto the topology. And wham, router 2 shows up. Now, router 2, before I even make any connection, you can see if I hover my mouse over it, it's showing me kind of the stats about this guy. But this router right here is ready to go. It's got an iOS configured. At this point, I can actually right-click on him and start him up. Let's do that. I'll click on Start. Takes a moment. It's loading in the background. There we go, it's running, and you can see the topology summary over here. It shows router 2 is now green instead of red. That means it's powered on. I can right-click on this guy and hit Console to open a console connection. And by default, you can see right there, it's using PuTTY. I hit Enter. It's already booted. It says, do you want to enter initial config dialog? I click on No. Nobody ever goes in that thing. And enter a couple times. And I am now sitting on a Cisco router. My router 2, I can change that label and things like that, but router 2, which is running the iOS. I can get in, show run, everything works. It looks, it feels just like a Cisco router. There's my config, go into global config mode, do show IP interface brief, see my my prompts, interface fast Ethernet 00. The problem right now is it's not connected to anything. I have no serial interfaces. That's going to come in a moment. Matter of fact, hang on, let me see where I am on my little chart. But Can we clap? This is amazing. Look at this. I so wish I just got like, ooh, or I need sound effects. Ooh, ah, fireworks. It's great. I mean, that's the real iOS running on a Cisco router in a lab environment. Now, very limited right now and very problematic right now. Let me show you something. I'm going to close my session. That's fine. And it's still running in the background. Again, just because you close the session doesn't mean anything. But when I hit Control-Delete on my system, look at this. Performance. CPU usage pegged. 100% utilized by one single router. And if I look and I say, well, what's using it? I see right there, 99% of my CPU is consumed by Dynamips, the engine behind GNS3. What's the deal? Well, the deal is that the Cisco router is not doing anything right now. It's sitting there idle. However, it has a process running on there that makes it think it's got its own processor and things like that, which when it translates over to your Linux or Windows system, it sees GNS3 or Dynamips as demanding 100% of your processor. I'm actually going to jump over all of this. Hang on. Let me get my other slide up and go to my tips and trips section, because this is huge. I should have put this on the core setup. Your PC is now dying. Use the idle PC. What the idle PC is a value that tries to identify, and I'll say tries, but tries to identify the process running on here that is consuming 100% of your CPU and idle it out. Now that doesn't mean that the router no longer has processor usage. If it needs it, it can get it. It's just not going to sit there idle consuming 100% of it. Now if I right click on this guy and hit idle PC, what GNS3 does for me is calculate an idle PC value. It's going to take its best guess, and most of the time it's right. Now I will say this will take some fuddling around with. That's what I call it when you're just kind of messing around, seeing how it works. It's trying to find a value, essentially the process in the iOS that is consuming 100% of your processor. Find it and then kill it. And you can see it comes up with all these different idle PCs. This is GNS3's best guesses at them. But notice it says potentially better ones are marked with a star. Now the good news is per iOS image you only have to find this value once, and in my experience most of the time GNS finds it right there for you. Number 4 is what it is. Now hang on, let's keep this up. This is your test right here, your task manager. I bring my idle PC over here, and as soon as I hit OK, let's watch. I click OK, it says I've applied it, and look at, did you see that? Did you see that? My processor utilization just dropped from 100% to nothing, to 0, even though router 2 is still running. Now, will router 2 consume processor cycles? Sure, if it needs it. But right now it doesn't need it. It's sitting there idle. So we're not going to waste it. And now, take a look at this. When I come back here to my iOS images, this is the screen where we initially added it, and click on this guy, notice GNS3 has automatically filled in the value I selected for that iOS image. So all future 2621XM routers that I add using this iOS, I don't have to do this for, and they're not going to eat up my processor. Huge, huge, huge to allow you to scale this GNS3 project. That's the idle PC. So let's get back to our main objectives. We need to build our topology, add some router modules, create our connections, and power the devices on. So let's bring that back up. We've got router 2. Let's add a couple more of these guys. Throw router 5 and router 6 out here. It just kind of generates the host names, and you can change them. Just right click on it and hit change the host name. Say this guy's router 1. You know, see what I mean there? So you can go through and change them to whatever you want, but we also have to add some modules to them. For instance, I might want to say, well, we need some serial ports. So I'll double click on router 1. Comes up with router 1 right here. I'll click on them. It says, you know, here's the general stats, memory assigned to them, and slots. So I can go through and say, well, you know, for the WIC slots, these are the WAN interface cards, I'm going to give it a WIC 2T. That's 2 serial ports on one WIC for WIC 1, and then let's do a WIC 2T for WIC 2. So I've got 4 serial ports plugged in this guy. Slot 1, this is where if you want to, you can add in, you know, for instance, the ether switch. NM16ESW is ether switch module, 16 ports. They have IDS modules and all of these different ones. So if you're ever curious, well, what is on that module, you can just Google that module number, go to Google Images, and you'll be able to see the ports and things like that. So click on Apply, and those modules have now been added to that router. Go to router 2, hit the slots, and let's just add WIC 2T on these guys. Again, I'm just kind of illustrating this. And now when I power actually before I power them on, you'll have the serial ports that are added in there. You can see it's now showing on the summary. WIC 2T is installed, 2 interfaces. So now we can get to the cabling. Now up here you can see there's some options, and if you hover over them, you can see like show host names, show interface names, and right there is add a link. Now I'm going to click on add a link, and it comes up with what kind of link do you want. I'll choose serial. Simple as clicking on it and clicking the destination. It immediately links those two, and you can see right here on the topology summary, it shows serial 0/0 is connected to from router 1 to router 2 on serial 0, and router 2 shows that as well. As you add more links, it's going to go through and cable them for you. Show also, you know, what serial ports are being used and connected to. Now, what about switches? Now, the good news is switch-wise, you can use, for instance, the Ether switch module to simulate like a real Cisco switch if you're trying to learn Cisco switches. But I would suggest if you're not really concerned about switching, just grab this guy, an Ethernet switch. Now, it looks like a switch, but it doesn't actually have a switch image assigned to it. If you double click on it, you can see that you've got switch 1. It shows, it's got an 8-port switch right here that you've got set up. And you can add ports if you want, but I can say, well, these ports are a member of this VLAN, and all this kind of things. You also have trunk ports that you can configure on this. Now, again, this is the switch. This is the configuration of the switch. So if you wanted everything on a flat Ethernet network, you can just leave it at default. And and again, this topology is going to get ugly, but we'll just do it for the fun of it. I'll do a fast Ethernet connection from this router to switch 1, this router to switch 1, and this router to switch 1. And you can see that switch 1 now has all of these different ports connected. Now let's say I wanted to isolate router 6. I wanted router 1 and 2 to be able to talk, but router 6 I want to simulate as if it's connected to another VLAN or another network. Well, that's as easy as double clicking on the switch and saying, okay, switch 1, port 3 is going to be a part of VLAN 2. Apply. Nope. I'll say port 3 is a member of VLAN 2. Good. And now I actually have port 3, which is isolated from VLAN 1 and essentially isolating from router 1 and 2. So at this point, I can click on these devices. Let me make sure I've got cable R connections, power the devices. I can click on these devices and power them all on. Or I can just hit this play button that starts every single device. So as soon as I do that, you can see it's starting the nodes. Everything goes green. Everything's powered on. You also see all these connections turn green. You saw that they were red before, which means they were not working. They were not powered on. So now I can access the console port of every single one of these devices. Click on console, and you can see PuTTY is loading. Okay, right now it's loading up router 1. Let's open Task Manager while we're doing this. You can see it's loading right now. Again, 3 routers booting at once is going to peg your processor for a little bit while it gets everything loaded. And there we go. It's now all booted up. We've got our processor back down to nothing. Again, you can see the routers, when they need the processor, will use it. But once they're there, they'll return back to that idle PC value. So now, when I go down to my console port, you can see they're all sitting there, and do you want to go into initial config mode? Now it even shows what router you're on up here. Now this is using the built-in PuTTY. I'll talk more about that in just a minute. But when I go in here and do a show IP interface brief, you can see all of these new ports that I've added show up. They're ready to configure. So I could go in, open a console connection to router 2. And get some base configuration put on there. Now, I was going to set up a little mini network and show that you can ping, but just trust me. Save me the time and you the time listening to it. You can go into every single one of these guys, into interface, serial 0, no shutdown, IP address, such and such, give it an IP address, all these different things. It is a real emulated router that is connecting between these two, running the Cisco iOS, so every command, every option is available to you at your disposal. So that's what I would say is the basic setup of GNS3. And keep in mind, I'm keeping it as basic as possible, but know that this thing has so many features. I mean, you can pop up the interface name, show all the interfaces on the topology. You can add pictures, images to the topologies, draw rectangles, because we all like doing that. I mean, again, you can do all kinds of things. I'm just going through the base configuration, base setup of GNS3 to give you the most common options. And at this point, we now have a running Cisco network that's ready to be configured. Well, let me wrap up by talking about some GNS3 tips and tricks to hopefully save you some time and some frustration as you're working with this software. As I mentioned, GNS3 is awesome, but it is free and it's open source. And if you've ever dealt with open source stuff, you know that there's some bugs and there's, it's kind of like, well, who do you complain to? No one. It's free. That's the benefit and the drawback of free stuff. So, with that being said, I've already talked about the idle PC. The best way to get familiar with GNS3 is to play around with the interface. To get familiar with this setup. Oh, hang on, let me move this over here. To get familiar with the interface, go through each one of these. Just kind of hover your mouse over it. Save network file, save file as, clear the topology. Figuring out what each and one of these buttons do can really help you out in working with it. The big thing that I want to talk about is saving your topology and your configurations. By default, and this is the biggest catch of all, if you go to File and hit Save, it's going to save the network diagram. But it does not save any of your configurations on there. The configurations are actually stored as separate files, little text files that the routers boot from. So you'll get very frustrated with this thing if you get this beautiful lab set up and then you go to save it and open it the next time. And the only thing you see there is some routers with blank configs, and you've lost all of the work that you've gone through. So first thing, and this is something I get used to anytime I start a new project or open GNS3, instead of just building the topology like I did with this, you always go to New Project. And you say, okay, the project name is such and such, whatever you want. And you can see it automatically puts it in the right project directory that you set up, the desktop in my case. And then you want to go through and check both of those guys. Save NVRAM and other disk files, and export your router configuration files. That will allow you to save all of the configurations with the project. You notice it also says, do you want to apply this to the current topology? So, and that's why I didn't mention it at the beginning, if you mess up and do this and then go, oh no, I forgot to set it up to save the configurations, it's like, no worries, you can kind of import this topology and save it as the other one. So that's where it goes through, and it can save all of the different configuration files with it. You want to make sure to do that. It's a simple but major time-saving change. Likewise, choosing a client for console connections. As you saw, this guy comes with PuTTY. So you can go in and right-click any of the powered-on routers and manage it through the console port using PuTTY. But you might want to use a Windows Telnet client, or you might want to use TerraTerm, or you might want to use Secure CRT or some other console program that you're using. That is all set using a simple option. If you go to the File menu, Edit menu, and go to Preferences, this is the general setup we saw when we started the program. You've got the terminal settings, and this is where you have your pre-configured terminal. Now you can see in this drop-down list, for instance, Secure CRT is in there, TerraTerm is in there, and stuff like that. But that's just because I had Secure CRT in, well, did I? No, you know what? I didn't. This is actually new. That's interesting. I guess in this version, I am using the 0.1 release before this one on my main PC. This is I just set this one up to demo, but they've added Secure CRT. Ha, that's awesome. Cool. I was gonna say, if you need to use Secure CRT, it's not gonna be on the list, but there it is. So I have nothing more to say about that. But if you didn't have Secure CRT, or there was some other program that you wanted to use, remember I showed you back in the beginning the link to the forums, this guy right here. This has literally got hundreds, if not thousands, of posts of people working with GNS3. And one of the things in there is how to get GNS3 working with Secure CRT, which is now a moot point in the current version of GNS3. So dropping down here, frame relay and virtual Ethernet switches. I gave you a brief flyby of this when I was showing you the switch that we set up and how you can configure just a basic switch with VLANs and things like that. But it also does support a frame relay switch, which, as you study for route, frame relay does add a lot of complications that Cisco wants you to know about, so it'd be definitely good to add a frame relay switch to your topology. Now, this frame relay switch is not like a Cisco router. You can set up a Cisco router as a frame relay switch, but the people or the creators of GNS3 said, why not make it easier? So you can go through and set up a service provider frame relay switch by saying, okay, we've got the port, which is what you connect devices to, and then you have the incoming DELC, and then the destination port, and the outgoing DELC. So for example, let me grab my pen here. Say you had two routers that you wanted connected to a frame relay cloud, and I'll talk more about frame relay when we get into the series itself. And you want to set up a virtual circuit between them. Well, remember with frame relay, it's kind of bizarro world to where the delc numbers are backwards. Let's say this is delc 201 and this is delc 102. Well, for router 1 to reach router 2 over here, it has to send to a destination delc of 102, flies through the cloud and comes out on delc 201, and vice versa. For router 2 to get back, it sends to delc 201, it flies through the cloud and comes out on delc 102. It's a little review from CCNA, and we'll do more later on. I just want to show you that when you're setting this up in GNS3, you set in the port number. So let's say router 1 here connects to port 1, and that's something you'll have to specify when router 1 connects. So I'll say port 1 of the frame relay switch is what it connects to, and this will be connected to, we'll say, port number 2. So I can change that to 2 right there, and I would say, okay, we've got 102 delc gets you to one side, and then what is it, 201 gets you back. Is that what I said over here? Yeah, 102, 201. So you can click on add and start making these mappings. Now, doing it this way is a lot easier than setting up a Cisco router as a frame relay switch. It's possible that you can drag a Cisco router into your topology and do that and set up the Cisco router. But I'm telling you, the Cisco router is not a frame relay exam. It's just what could happen in a frame relay style network. And so setting up a Cisco router as a frame relay switch is definitely not necessary. I would highly suggest using this guy because it's just a lot easier configuration. Last but not least is the Wireshark captures. This is probably one of the most amazing features, in my opinion, of GNS3. The fact that you can go in here between these different routers, and let's say you really want to know what's going on behind the scenes. You really want to know what kind of packets EIGRP is sending, or OSPF area border router is sending between the two different devices, and you want to get a Wireshark capture. Well, obviously, it's an emulated environment. How do you do that? Just simply click on the link, right-click it, and hit capture. It comes up and says, well, what source interface do you want to capture? You click on OK, and it's going to go through and create a packet capture for GNS3. And you can then export that into Wireshark and analyze the packets, and it's actually capturing the real packets that are coming in from the router, because it is real packets that are being sent between these different devices, and you can export them into Wireshark for further analysis. Now, if we really had traffic going and I really had Wireshark installed in my little test machine here, as soon as I clicked OK and started the capture and then ended the capture, it would actually export it and automatically open it in Wireshark. You can see when I go to the preferences, I have this capture tab, and this shows this is where it's storing the capture files. So I would suggest changing that to something maybe on the desktop or easy to find directory. And then it says, what program do you want to start? And it shows Wireshark when you're doing the capture, and you can see automatically start the command when capturing. So what it's going to do is take whatever directory you have here and automatically open it up in Wireshark. Now, I don't have Wireshark installed, which is why nothing happens when I click on that capture button. But that is an amazing feature that really allows you to get some of the in-depth of what's going on in the Cisco realm. So there it is, GNS3. Probably one of the coolest utilities to come out in the last well, forever, for learning Cisco. The ability to emulate Cisco devices rather than simulate is amazing. So I hope you find it super valuable as you study, and I hope it's valuable not only for this series, Cisco Route, but also if you choose to go on for your CCIE, and I hope it saves you $11,000 in eBay gear that you eventually have sitting in a garage that you have to resell or something like that. With all this being said, I will say GNS3 will take some playing around with. It probably will crash if you do something wrong that goes outside the bounds. It is open source, and you can get frustrated with it, but all of its quirks aside, it is an amazing way to emulate and work with Cisco devices. Hope this has been informative for you. I'd like to thank you for viewing.